Example 2, consider f of x equal x squared plus 2x minus 5. We're going to end up graphing the thing, but it says complete the square to convert to vertex form. Remember what vertex form was. Vertex form is this, all right? So they want it to look like this. Now, is this the easiest thing in the world to do? Probably not. I think the reason that we would do that is to find the vertex. What's the easiest way to find the vertex? Well, the easiest way is probably to graph it. Check it out. If I go x squared, what was it, plus 2x minus 5. You could just, you literally go to Desmos and just find the vertex right here. There's the vertex, -1, -1, -6. I see the vertex right there, okay? How else could I find the vertex? I could do -b over 2a and do the same thing that we did on the last example. I could do that. I know the vertex is -1, -6, but they want me to use completing the square. So we know how to do completing the square. We can do this, all right? It's a little bit different than the way we've seen before. So check it out, all right? We've got x squared plus 2x, and I'm going to leave some space, and I'm going to move that -5 way over there, okay? Notice we're pretty much going to ignore the f of x. I'm not even going to look at the other side, f of x. I know the last time we did it, the other side was equal to 0. This time we don't really have the equals 0. We're only looking at this, okay? But mainly we're doing the same thing. Remember what we do. We put a blank there. Put that blank there. We're trying to fill in that blank. Filling in that blank is completing the square. And what we do then is we look at this number right here, and we say half of that number is 1 and put it down there, right? Remember doing that? Half of that number is 1, and you square that number back, and it goes in this blank right here, 1. 1 squared is 1. That goes in the blank. That's completing the square. So if you notice, this trinomial expression right here can be factored. X squared plus 2x plus 1 factors into x plus 1 squared. We've just completed the square. We've completed the square, but we've also thrown our equation off, okay? We added that 1. This 1 was not really there at all, right? We put a 1 into the equation that wasn't there. And so in the past, when we did completing the square, I said, what are we going to do? If we add 1 to one side, we're going to add 1 to the other side, yeah? But right now, I don't really have an equal sign, so I don't have another side. So I'm going to have to use an alternate method there. If I add 1 and throw my equation off, I'm just going to subtract 1 and put it back on, okay? So now I'm balanced out. If you add 1, you subtract 1, no harm, no foul, right? No harm, no foul. So I've got x plus 1 squared minus 6 right there. And so complete the square to convert to vertex form. That's vertex form. And vertex form is useful because I can see the vertex there. The x part would be -1, and the y part would be -6. And that's exactly what Desmos told us a minute ago. 1, 2, 3, 4, 5, 6. There's the vertex at -1, -6. Okay? Question?
Why is the 1 negative?
Why is the 1 negative? The way I look at it is you're trying to find the center of the parabola, okay? And so you're trying to find, like a distance of 0 away from the center, okay? So what I always do is I always look at this expression right here and say, what is going to make 0? Or in other words, 0 away from the center of the function. So if you look at that, -1 plus 1 equals 0. I'm looking for -1 to make that 0 away from the center. Okay? But that kind of thing happens in other equations too, like circles. We did circles before, and when we found the center, it was, a lot of people will say, well, it's the opposite. And that's not a very mathematical way of thinking about it, but that'll get you there a lot of the times, okay? So there's your vertex at -1, -6. It says graph the function. And, again, we've got it at Desmos, but the problem with this, if you just tried to copy it, you're still going to have to come up with some points. Okay, you're going to have to come up with some points so you can graph. Here's one, and maybe here's one. I don't know. But I think the best way to do it is that 1, 3, 5 pattern. All right, remember the 1, 3, 5 pattern. You take this number in the front, 1. Again, if that was anything else, you'd have to multiply it. But since it's just 1 times 1, 3, 5, you're just going to use your 1, 3, 5 pattern. And so what I do by that is I'm going to go from my vertex. You always start at the vertex. That's the center. And you're going to go up 1 and over 1. You're going to go up 1, 2, 3 and over 1. Going to go up 1, 2, 3, 4, 5 and over 1. And that should be plenty. If you go up 1, 3, 5, that should be a really good looking parabola. We can graph that thing, shoot a curve through. Something like that. Part C says give the domain, the range, and the axis. Okay. Domain we've talked about. Domain is just the x numbers. All right, right? It's the input numbers. I like to look at it as if I squashed this thing down onto the x-axis, what would get covered? Okay, everything, right? The domain is going to be all real numbers. Negative infinity to positive infinity. The range is the y numbers. And so, again, how I think about it, I like to think about it as if I took this parabola and squashed it onto the y-axis, what's going to get covered? If I squash that thing onto the y-axis, it's going to cover everything from -6 and up. From -6 and up on the y's, or from -6 to infinity. And so that range is going to be bracket -6 to infinity. Why is it a bracket? Because it could equal that -6. It won't equal the infinity part, but it could equal the -6. Now, the axis is something we haven't really talked about, I don't think. The axis of symmetry is like an invisible line that shoots right through the middle of the parabola. Imagine if you took the left half of the parabola and folded it over that line, it would completely cover and be right on top of the right side of that parabola. Yeah? That's the axis of symmetry. It definitely has to do with the x number of the vertex, -1, but the axis of symmetry is going to be given by x equals -1. X equals whatever the x part of the vertex is, okay? So get a hold of that. They're going to ask you that something about the axis. It's just going to be the x part of the vertex. D, find the intervals over which the function is increasing or decreasing. A lot of students miss this one, okay? Because you look at the problem and you're like, well, it's increasing right here, right? This is the part of the parabola that's increasing. And so what people do is they'll say, well, it's increasing from -6 to infinity up here. And that's not what they're wanting. When they say intervals, they're talking about domain, okay? So when they want the interval for which this is increasing, they want the domain for which this is increasing. And the domain for which this is increasing, squash that onto the x. Squash the increasing part onto the x. They're only talking about from -1 to infinity. They're talking about the x number, not the y number. Okay? So even though you're looking at the y number being the part that's increasing, you're looking at the x number for the interval. And so it's increasing from what? -1 to infinity. Now decreasing, this parabola is decreasing on this part of it. Okay, now again, a lot of people will say, well, it's going from infinity down to -6. And yeah, that's true. It is going down to -6. That is how you're recognizing that it's decreasing. But when they say the interval, they're talking about the domain. So you're only really looking at the domain for which that thing is decreasing. Okay, look at the domain part. Squash that onto the x. It's going from negative infinity to negative 1. Decreasing from negative infinity to negative 1. Bracket.